So in this problem, we need to find a point, a suitable point, such that when we shift the origin, the equation x squared plus xy minus 3x minus y plus 2 equals to 0, it's no longer going to continue any first degree term or a constant term. So let's begin. So let's say, let the point h comma k be the new origin. And if it is the new origin, then we're going to make the substitution that we are going to substitute x with x plus h and the value of y with y plus k. So that means our equation is going to become, we have x squared plus xy minus 3x minus y plus 2 equals to 0. Let's substitute the value of x with x plus h and the value of y with y plus k. So we have x plus h whole squared added to x plus h multiplied to y plus k minus 3 times x. So the value of x is going to be x plus h minus the value of y. So y is y plus k plus 2 equals to 0. We're going to expand it. We're going to get x squared plus 2 times x times h plus we have h squared. Then we're going to take the product of x plus h with y plus k. So we get xy plus xk plus h times y plus h times k minus 3x minus 3h minus y minus k plus 2 equals to 0. So here we have x squared. We're going to combine the terms. So let's take x as the common factor. So here we're going to take 2h followed by we have k plus k minus 3. Fine. Then we're going to take y as the common factor. So we'll have h followed by negative 1. Fine. Then we have the term xy and then we have all the constant terms. So we have positive h squared plus hk minus 3h. We've already taken this negative y common, 3h minus k plus 2. Fine, this is going to be the constant term that's equals to 0. Now we're going to apply the condition here that this new transform equation, it does not contain any first degree term as well as it does not contain any constant term. Since it does not contain any first degree term, now clearly this is the first degree term because the degree of x is 1, and then we also have this particular term where the degree is 1. So this is also a first degree term. So this term is not going to exist also, this particular term, and we also don't have the constant term. So that means these must all go to 0. So we'll take 2h plus k minus 3 equals to 0. We have h minus 1 equals to 0. And then we have h squared plus hk minus 3h minus k plus 2 going to 0 as well. This is not going to 0 because this is not the first degree term because the degree of x and y are both 1. So together they may have a degree of 2. Now let's solve for h. So we'll have to use this 3 equation to find out the value of h and k. Well, starting with the h minus 1 equals to 0. So that gives us h equals to 1. We'll substitute this value. So we have 2 times 1 plus k minus 3 equals to 0. Solving for k, we get the value k equals to 1. We can check that out. If we substitute h and k into this equation is also going to get satisfied. So we have 1 squared plus 1 times 1 is 1 minus 3 minus 1 plus 2. So this is going to be equals to 0. 1 plus 1, that's 2. 2 plus 2, that's 4. So 4 minus negative 3, negative 1, that's going to be 0. So the values of h and k are 1. So that means this is the particular point. The new origin is going to be having the coordinate value. We're going to call it O prime, coordinate value 1, 1. This is the point where the equation, the transform equation, is not going to have any first degree term as well as the constant term.